The Collatz conjecture, also known as the 3-in-1 conjecture, is a captivating unsolved problem in number theory. It's named after the German mathematician Lothar Collatz, who proposed it in 1937. Despite its seemingly simple formulation, it has proven to be a remarkably tough nut to crack, and remains one of the most famous unsolved problems in mathematics. The conjecture is about a sequence defined as follows: start with any positive integer n. Then each subsequent term is obtained from the previous term. Using a simple rule, if the previous term is even, the next term is 1/2 of the previous term. If the previous term is odd, the next term is 3 times the previous term plus 1. In mathematical notation, the sequence can be defined by the function fn n2 if n is even, fn 3n1 if n is odd. The Collatz conjecture asserts that no matter what positive integer you start with, eventually the sequence will reach the number 1. In other words, for any positive integer n, there exists some I such that fin1, where phi denotes the ith iteration of the function f. The conjecture is simple to state and understand, but it has proven to be incredibly difficult to prove or disprove. It has been checked for all starting values up to 260, a number with 18 digits, and the conjecture holds true for all these values. However, a general proof or counterexample that applies to all positive integers remains elusive. The Collatz conjecture is fascinating because it's a problem that is easy to understand and explain, even to someone with little mathematical background. Yet it seems to defy all attempts at a solution. It's a reminder of the fact that in mathematics, simple questions can lead to deep and complex problems. The conjecture has inspired a large amount of mathematical research, and a proof or disproof of it would be a major breakthrough in number theory. Despite the difficulty of the problem, the beauty of its statement and its tantalizing blend of simplicity and depth continue to captivate mathematicians. The sequence generated by the Collatz function exhibits a seemingly chaotic behavior for most initial values, but always seems to end up in the cycle 4, 2, 1, 4, 2, 1. This is what the Collatz conjecture asserts, but why this should be true is not understood. The difficulty lies in the fact that the function f alternates between dividing by 2 and multiplying by 3 and adding 1. Two operations that have very different effects and are hard to combine in a useful way. Despite many attempts, the Collatz conjecture has resisted all efforts at a proof or a counterexample. It stands as a testament to the fact that in mathematics, some of the simplest looking problems can be the hardest to solve.